Live from our Lakeview studio in the Windy City, welcome to Chicago Python's Data Special Interest Group event. My name is Ali Sivji. I'm one of the ChiPy organizers. I'm going to be your host for this evening's event. Really excited for everybody to come join us. Let me share my screen and we'll get started. All right, but before we do start, I want to make everybody aware of our code of conduct. I can't really do it justice by summarizing it in a few sentences, but the main gist is be considerate of other people and try to treat people the way you would like to be treated. More information is available on our website. The Chicago Python Users Group is a tech-focused community that was founded back in 2003. We've grown from our humble beginnings where folks were meeting in very small conference rooms and meetups to being one of the largest Python communities in the world. We have over 6,000 members. In addition to our monthly meeting, which happens on the second Thursday of every month, we have special interest groups that focus in on more niche areas of Python. We have one for finance. Chicago's a big finance hub. We have one for data, which is this event. We also have one for web dev / DevOps. And we have one for algorithms and data structures. And here you're going to be working with a group of people on leak code and hacker rank type problems to get better at those interview type problems. I want to make everybody aware of some upcoming events. Can't believe it is October already. So it's October 22nd, which I believe is tomorrow. We're going to be having our lunch breaks, and it's going to be on asynchronous programming. Check us out on Meetup for more information about that. We also have some events upcoming in November. We have our Algo SIG, our main meeting, and tentatively we're going to be doing a project night. If anybody would like to help out and come up with a new project, please reach out. Would love to help. So what else is going on in the world? PyTexas is happening this weekend. PyTexas is an annual conference hosted in Texas, usually in Austin. Sometimes it's been in Dallas. They've moved from Austin Public Library to being a virtual conference, and that's going to be happening this weekend. More information is available at pytexas.org. I should have one of my talks accepted, so if you'd like to see a premiere of a facade pattern talk, check it out. Tickets are free. Highly recommend. It's going to be a lot of fun. Where can you find more information about ChiPy? You can talk with us, ask some questions about Python in our Slack. We have around 2,000 people on that Slack. It's fantastic. You can go to that URL, send yourself an invite, and join the community. If you're on Twitter, we are also on Twitter. Check us out at Chicago Python. And all this information, plus a lot more, is available on our website, which is chipy.org. All right, so that's enough about ChiPy, enough about me. Let's talk about tonight's event. We have two fantastic speakers. Our first speaker is Thomas Yager-Madden. He's going to be talking about a tool he built that allows folks to process raw SQL queries using SQLAlchemy. And then we're going to have a break. And then after the break, we're going to have Stephanie Kirmer talking about tree-based anomaly detection. So you got a little preview of the slides with some graphs. It's going to be very interesting. Looking forward to it. Check out our live chat feature, which is going to be that way to my, what to say, right? Because it's always the opposite. You can interact with our community, interact with folks. Remember, anytime you're interacting in a ChiPy space, you have to follow the rules of our code of conduct. You can also ask questions for our speakers. Very excited about that. All right, so that's enough about that. Let me minimize my screen, and we're going to bring on Thomas. Welcome, Thomas. How you doing tonight?
Hi, I'm okay, thanks. Good to be here.
Where are you calling in from?
I'm up in Wilmette, actually.
Yeah, awesome. Yeah, I think we have a Chicagoland show, so very happy about that. So can you please introduce yourself to our audience?
Sure. My name is Thomas Yager-Madden. I am currently the data architect for an ed tech startup here in Chicago called BenchPrep. where I've been for coming up on just 2 years, actually, in just a few days. It's been a great couple of years. Before that, I have really like a 20+ long year career, like entirely, well, since I stopped making other people's food, it's all been really databases and data management. I've kind of moved around in different roles. I've had much more of like a design kind of data modeling sort of a role for a long time, but then kind of pivoted about 7 or 8 years ago to more of an operational DBA kind of a job. And now I'm in a sort of more senior position where I get to combine really kind of all of those skills.
Okay, awesome. So how did you first get into Python?
Well, I would say just basically because I've spent most of my professional life working, with and around data and databases. I've just found that like Python was sort of a natural, like that's one of the more commonly used languages in the sort of community of practice, in that area. So that was just kind of always there for me. And as I needed to sort of automate more of my kind of mundane tasks, I just kind of started leaning on it kind of more and more.
Yeah, I mean, it is I think they say it's the second best language for everything. So yeah, definitely hear that. But we are like into October now, and we're still sort of dealing with the effects of sheltering in place. Do you want to talk a little bit about your experience and like what you've been doing for the past, I'd say like 6-7 months?
I know it's crazy how long it's been, and it's I don't even know what to say about that. I mean, I consider myself, I'm obviously privileged and fortunate in many ways, and I have a career and a job that I can, nowadays I can do from anywhere with a laptop and an internet connection. I don't have to leave the house to do my job, which makes me much safer. My family and I live in an affluent suburb. We're going to be fine. But it's difficult. I think so many things, but I think the one thing I wanted to mention, because I don't often hear about it otherwise, is for myself, like I find I'm a creature of habit, and there are certain things that are a part of a person's like daily routine that you might not even notice, but that the best metaphor I heard for them, it's like they turn out to be like load-bearing walls, right? And when they're gone, like it's much more difficult to do without them than you would have ever thought, and this was a thing, I think, having to kind of switch and stop going to an office every day, and all the other stuff, how it is in the community and kids in school and having them at home, anything that was my routine before, most of it's gone, right? And I've still have not, even as many months as it's been, I don't feel adjusted to that really on a daily basis at all. And so I think that's the thing that for me is the hardest, is just getting through the how strange everything is, even while I'm at home. Like this is my own house and I feel at home here. And yet I'm also the world was already a strange place, and now it's so much stranger.
Yeah, it's like I don't have that routine. It's like going into the office. Like that's when I used to catch up on my podcast. Until the past like couple weeks, I have been months behind on every single episode, and it's just been difficult. Just trying to adjust to all these like different things.
Yeah, that little bit of time on a train or a bus or whatever, when you can just kind of zone out and have that to yourself and do whatever. It's weird how you don't get there's no replacement for that. Yeah. Unless you make one, unless you carve out a time and say, I'm going to have a podcast half hour or whatever. Yeah. Yeah.
It's going to be interesting to sort of see how we cope coming into winter with just like restaurants and bars are going to be like, they have outdoor seating, but winter's cold. I know in Europe, they just put on a jacket and keep going, but I think it's going to be like being like at a ski chalet, sort of the same type of thing. Well, at least that's what I'm sort of hoping for.
I'm hoping it's not, like The Shining.
Yeah. Okay. We can close off the interview part at that.
I don't want to freak out. Yeah. No.
Are you ready to start your talk?
Like I said, we're going to be fine. Absolutely. Yeah. Let's go. Yeah. Let me share my screen, I guess.
Yeah, that'd be great.
Get that going. Okay. This one and that one. There it is.
Your screen is up. Please take it away.
Yeah. So I am here this evening to talk about this module that I wrote that's called sqla-raw. SQLA, of course, short for SQLAlchemy. And I just wanted to start by saying really that this was not originally my idea to come and talk about this. This was something Ali asked me to do, but he did convince me that it would be a good idea, and I'm glad to be here. So what happened was I happened to mention in the Chicago Tech Slack that I think somebody posted one of the other ones. I think it'll come up later, AIO SQL, that does a similar thing. And so I just replied and said, if somebody's looking for something like this, I also wrote this similar thing that you might want to look at, just for whatever that might be worth for people. And then Ali jumped in the conversation and said, hey, I'd love for you to give a talk to the data SIG at ChiPy about that. And I was like, oh, really? Because to me, it's a kind of a small piece of software. But then he said, what you see on the screen here, Ali said, building a toolbox is a useful skill. And I think that's very true. And so that's really what I kind of want to talk about. I am going to be talking about a module that I wrote, but I don't want it to seem like an ad or like I'm trying to convince you to use it unless you have a good use for it. But I wouldn't say like discourage anyone from using it who might be interested, but I might convince you, if you wanted to do a similar thing, but you had like differences of opinion with how I did it, you might consider making your own rather than using mine, because it's a sort of a small enough effort and it's a worthwhile enough thing to do. And I'm sort of here to talk about why you might do that. So this is not like a packaging how-to either. Like I said, it's not an ad for my module, but I'm also not, if you don't know how to write like a setup.py, or if you don't know how to use Twine to upload things to PyPy, like I didn't know how to do that not too long ago either. And I found that just the standard official documentation on those tools was adequate, was actually quite good. So I think you can learn that for yourself. But what I'm really here to talk about is kind of more like, what was my thought process? Like, right, like why did I think that there should be this module? And then when I had decided that, like what I did to make it happen. So let's start with, why would you want a library for sending raw SQL to a database? And really for me, it's mainly because I'm not like against ORMs. Well, I mean, I am, but no, not really. I mean, I think I'm against them the way that like, it's like I'm a vegetarian, right? But I don't mind other people eating meat. It doesn't offend me or seem immoral to me or anything like that. It's not for me. And ORMs really are not for me. Although I would refer you to this blog post, and I'm going to post these notes on the internet after the talk, and there'll be a link in the comments and here at YouTube and at the meetup. But Eric Bernardson, who used to be at Spotify and wrote Luigi, which is a great Python sort of pipeline manager, did write a really nice rant against ORMs if you like that sort of thing. But really, it's more that, I think that if you're going to be interacting with a database, SQL is an excellent tool for that. And it's certainly the one that personally I know best. I've been working with it. It's been around for 50 years going on, and I've been using it for more than 20 of those years. So I think it's the right tool for the job. And then the other thing is that I write a lot of SQL anyway. And I have written a lot of SQL, and I have it saved, and I have it in version control. And one thing that's a very good workflow for me, if I need to automate something, is to sort of work it out manually first. So if I can be, in my favorite editor and just writing my SQL code, and then going to pSQL, my favorite command line client, or whatever client I might be wanting to use, and submitting that SQL and seeing what results I get back, and if those are the results I want, and does it perform the way that it needs to, and if it doesn't, how can I tune it, and doing all of that kind of stuff just as SQL. But then if that's something I need to if that query is something I'm going to need to do like repeatedly or for various different reasons or with some small changes, but kind of the same thing over and over. If it's, in other words, if it's a process that I want to automate, then it's nice if I can take that same SQL and like reuse it in a Python script. But I'm trying to make that easy to do. So the other thing that was sort of important to me is having the results come back from that query just as something. My personal favorite is this list of dictionaries with the column names as keys. I think that's it's not the most compact format, but it's super easy to if you get one of those back, it's super easy to figure out what's going on inside a result set like that. If you don't know what columns to expect back or whatever, you'll find your way around inside there pretty easily. Now, of course, it's not impossible to just take a Python database driver like CyclePG for Postgres, which is what I use the most, and just make a connection and create a cursor and execute your SQL against the cursor and get the results back and format them the way you want. But there's a lot of sort of, if you're doing that in every program that you're writing, or multiple steps of the same program, even it's sort of cumbersome, and there's a lot of kind of boilerplate that you have to step through before you're actually like executing the SQL. You're just kind of doing the same thing over and over again. And then at the end of the day, if you want your thing to be able to work with maybe different things, if you needed to switch out something that you were running against Postgres and run it against MySQL or SQLite or something, you're gonna have to get a different driver in, and then all that code is gonna have to change. And then the other thing was that I did come up with a way of answering some of these problems, but I was repeating myself with it. I had this little script, this db.py that I wrote, and I kept writing it kind of over and over again, and they were all not exactly the same, but the differences were kind of slight. So what I really want, at the end of the day, is I just want a function I can call that will take a string that has SQL in it, send it, connect to my database for me, run that SQL, and then get the results back, and know what to do with them. So there are actually a few things out there that do this, and I'm going to be my little bullet points here. I felt bad because I noticed as I was getting ready for this that they were all negative, and these are all like fine, I think really excellent software, and there might be others. The reason these ones are on my list is because I actually happen to think they're good. So the reason why I have these negative things is like, why didn't I use them, right? So Pug SQL I think is great. It's based on this Hug SQL library from Clojure, but the thing that's kind of weird about it is it works by like you put these special sort of magic comments in the SQL, and so if you're sending them to the database, they're just comments and they just get ignored. But the Python in the library extracts them and parses certain things out of them, and you have to format them a certain way. And that's cool because if you go through all that, then when you're done, you can just kind of make a method call, and it's that query, and you get the results back. But it just seemed like there was a little too much kind of magic in that comment stuff, and I wasn't super fond of it. There's this other one, AIO SQL. That was the one that had gotten posted in Slack. That does another little tricky thing with comments, but it's not quite as magical. But it only works with MySQL and Postgres. One thing that's good about it is that it can support either regular or async IO drivers if you need that sort of thing. If you need that and you know why you need that, you're like smarter than I am. But I think it's cool, but I've had a hard time getting my head around it. And then there's this other one called Records. I started out using Records, and unfortunately it got sort of abandoned by its developer, it appears, and so that wasn't great. And then the other thing was that all along, the developer of it has this other library called tablib, which it's a cool kind of thing for making tabular data sets sort of easy to handle in Python, but it was just a little bit heavier than I felt like I wanted. So even before the developer of records had kind of archived it, I was already kind of leaning away from it because of having to kind of have all this tablib sort of infrastructure in the background that I wasn't really using. So after a while, as I say, I wrote this little db.py, which I'm going to show you kind of an early sketch of it, I think, if I can manage to switch over to it without too much trouble. I think this is it. Yeah, there it is. So you can see it just like it just makes a connection and returns that. It instantiates what SQLAlchemy calls an engine, which just, I think, I'm not even sure, that gives it a way to connect and load a dialect and various things. And then you can create a connection against the engine and then return that connection as an object. And then result, which simply takes like some SQL as an argument. And then the reason why there's this like quargs thing into that. So there's really just these, it's a very short, as you can see, just this little thing. Now let's get back to my notes and I can figure out where I was. Is that the right thing? Yeah. So I took that little script that you just looked at and I threw it in a gist on GitHub, and I sent it to some friends and said, this is all of the SQLAlchemy you really need. And I was just kind of kidding around about ORMs and stuff by saying that. So what's kind of cool about SQLAlchemy is that they really put a lot of time. Like, we think of it as this big ORM, and it is that, and the ORM is pretty cool. But it also has this whole just kind of like SQL and like engine side. That is really, if you start looking at it, which I did, I started looking at it closely, and it's just quite an accomplishment. That, you know, it can talk to just out of the box, you know, not just MySQL and Postgres, but commercial things, SQL Server and Oracle, and several others. You know, there's about a dozen, I think. And then you can get extensions that will let you load like even more. And then it lets you kind of write SQL in sort of a standard way, and it knows how to kind of translate into different, you know, different dialects for different vendors. And so that lets it do kind of cool things. Like if you use this text function, which casts it into what SQLAlchemy calls textual SQL, you can use named bind parameters, like no matter which, like in Postgres, for example, there are only positional bind parameters. And that's hard sometimes. I think named bind parameters are super easy to use. And you can use them no matter what database you're talking to if you're using SQLAlchemy. And then the other thing I found really convenient is that when you're creating the engine, you can just pass it a URL, and it figures out from the protocol like which driver it needs, and what dialect it's going to put in the engine and all of that kind of stuff. And using, I think, a database URL in like just setting that in the environment and then passing it in to the create engine it's sort of recommended 12-factor practice. And it's not just that I've like drunk the 12-factor Kool-Aid, but I think the arguments there about keeping configuration in the environment and about treating external services like a database as attached resources, I mean, it's just kind of hard to argue with that. And SQLAlchemy implements that, you know, just perfectly without any effort on really my part. My code does is it does the thing I wanted up above, which is that once it gets those results back, it just figures out what the column headings are, and returns a list of dictionaries. I have thought about making it possible to at least optionally just get back tuples with the rows instead, just with the row values in them in order, because that's a much more compact format, and it would be better, I think, you know, in cases where the size of the result over the wire or various optimizations you might want to do, that could be important. And it just could be easier to access in the code in that format, in the, you know, the client code that was going to consume it. I could also have it output CSV, but that seems like something maybe you would want to get results back first and then convert that in the code. So after I'd sort of shared this just around, people actually said, hey, this is kind of cool. And it's so small, but it just started to seem like kind of important to me. And like I said earlier, I had noticed that I was actually using this pattern like a lot. You know, I would just kind of have to, but I would have to copy and paste it from my, oh, here comes my cat. I would have to copy and paste it from my other project, into this new thing that I was starting. And that didn't seem, that didn't seem great. And I'm going to talk more about kind of under lessons later at the end. You don't want to keep so it seemed like this is time to make this into a thing that I can just import. So then it was worth packaging. So I took my script and I made sure that it was in a folder that had a dunder in it, which makes it into I guess a package or a project. And then I wrote a setup.py for it. I added a little test at the end. It's only one test, but it actually, I think it's such a small enough piece of code that actually probably proportionally gives me, as good test coverage as just about any library out there, ones you're probably already using. I open sourced it under the MIT license. And then being able to upload it to PyPy means I don't have to keep track of it anywhere else, right? I have my code base that has the actual module. But in other projects that I'm working on, I'm no longer pulling that script in. I just say, well, I'll have the demo, I just say import and start using it. And then from there, the next thing that I think is once you have it and it's in GitHub and it's public, then it's a thing. And so then I can improve it and make changes to it. And it's gone through, it's got a couple bells and whistles that it didn't have at the beginning that you'll see. I'm going to do a little demo. And why don't we do that now, as a matter of fact? Okay, yeah, I think I'm doing all right. Let's hope this works. Yeah, there we have a terminal. So I have already, this is a little folder I created just for this demo, and I created a virtual env in it, and I've installed sqla-raw already, and so we're set to go. I think the only thing I wanted to do is before I start, I think you should maybe see this little query that I'm going to use at one point. So what I did was I made a little database here locally just on my laptop, and our friends at Divvy, the ride-sharing people, share public data. It's like anonymized data about all the rides that people take on their bikes, like what station they picked them up from and where they dropped them off and what time they got it and what time they brought it back. And I think there's some other stuff in there, the latitude and longitude coordinates of the stations and things like that. And then it's all sort of timestamp. So I loaded that all into a table just for the most recently available month, which was September at this point. They come out sort of following the last month. And then this was an interesting query that I just thought up and thought would be kind of fun to see. So I'm just figuring out how long on average did people have a bike checked out, and then what was the longest on each day. So it's grouped by day and it's grouped by, they have this rideable type, which is whether it's an electric bike or just one of the regular, they call it a docked bike, just a regular bike that you pedal. And then date trunk by day. We'll group things by day. The other thing here is that you'll notice down at line 7, there's a Jinja tag. So this was one of the bells and whistles I mentioned. I added the ability to use Jinja 2 syntax, which is a templating language that's pretty popular in Python. And so that way you can have things like what I'm doing here is if it receives an argument for this type the named bind parameter in line 8, if it gets a type passed into it, it'll come in from the quargs, the keyword arguments. Then it should render this. Otherwise, just skip it. So that's kind of cool because I can either run the query with no filter at all, or I can tell it I want to filter by dock bike or by electric bike. And if I add that argument, then it'll automatically add the where clause, and I can use the same piece of SQL in kind of 2 different ways. I will say there's maybe I'm using what Jinja calls a sandboxed environment, but I wouldn't use a lot of like variable, like the bind parameters exist in SQL for a reason. I say in the documentation, like, don't use this Jinja thing with any untrusted inputs. We don't want any like SQL injection happening. I don't think there's a great risk of that if you're not like expanding variables. I've thought about trying to add some kind of thing that would actually like Lex the template and not let you expand variables. That might come later if I decide it's worth the effort. But in any case, right now it does do Jinja, and I think that's safe enough as long as you sort of know what you're doing with it. Otherwise, don't. And we're going to use it here, and then we'll see what those things are when we get in the demo. So I'm sorry, I'm kind of going on and on at this point. Let's start. So we're just going to actually go into like a Python prompt. I should probably, can I? Oh wait, I gotta. There we go. Clean up a little bit. So I just want to, wait, actually, it's from raw, import DB. Got it. And so now let's see what that actually does. There are some little helpful comments that will help explain. So really, like, we don't really ever need to interact with connect directly. That's just a function that's there so that result can use it. And then process template kind of similarly gets called by result if there's a little thing where I just have a regex that looks for template tags. And if it finds them, then it sends it to process template. And if it doesn't find them, it skips it. In any case, then once it has the thing rendered, we can just call result, and it's gonna send the whatever it gets as SQL, and then the key values from the quargs are gonna get sent as like bind parameter values to anything that's like a colon prepended key in the SQL. And that's just a SQLAlchemy kind of standard thing for bind parameters, that colon notation. So now we can actually, I already imported it. So I can show you an actual, like just a super simple, like, hey, it works, hello world kind of result. We can just select the literal string foo as var. And then there it is. We get a list of dictionaries, just one dictionary bar foo. So then just to show that we actually are connecting to the real database, let's get some Postgres specific sort of function values back. And this helps me verify that I'm connected to the right place. Yeah, I'm on Postgres 10, and the current database is raw demo. So now, here's an interesting little thing. Not a table. There's not a real table in my database. And so what happens? So what sqla-raw will do at this point is sort of capture the error, the exception that gets raised from this database error, which is that this table does not exist in the database. But what it's going to do is just make error the key of that and essentially return it as if it were a result. And my thinking there was that we certainly want to, like, any code that is actually calling this function and getting something back, we certainly want it to know that there was an error. But I don't want, like, really an exception to be raised there. I don't want the calling of the database to be the point at which my, like, larger program falls over, right? Because there's going to be errors. Your database is, sometimes it's not going to, you can't make a connection to it. It's not going to be there. Maybe it went down. Or there's something wrong in your SQL, like you tried to access a table that doesn't really exist, or that you don't have permissions to. There are so many, like, errors that you can get just trying to communicate with the database. We sort of need to be ready for those to happen. But like I said, I don't want that to be the place where execution is going to halt, right? The thing that's calling this wants to get something back, but it wants to be able to keep going on with its life. And then the other thing I guess I could have done was taken just the exception object and handed that back. But now my consuming code has to either it's got to deal with one of two things, right? It's either a result set or an exception. And I kind of wanted to be in a position where it's always going to at least look like a result set, and then you can introspect it and find out if there's an error. And then if you want to do something about the error, you can, the other code can handle all that. But this is a design decision, and it's not necessarily the best one. It's the one that seemed best to me. And I would just want to be clear about that because I think that's the kind of thing I'm really talking about, is like, how do you make these choices, right? So now let's actually do that big, exciting query. I actually have to type this one, wait. I'm gonna load it into a variable this time, so it'll be easier to look at. So this time, what result from file does is it's just a little wrapper around just going out and reading a file. You just pass it a path, and it reads that, and it will, then once it's read it, then that's the SQL, and then it just calls the regular result function. And I'm gonna, because you saw I had that little cool kind of Jinja thing at the filter, we're gonna look for just the docked bikes this time. And if I did this, if I typed everything right there, that's actually going to take a second, which is nice because there's a lot of records in it. And it's just a big flat table. I didn't create any indexes or do anything to it. I just dumped it in there. And so now let me just, it's going to be hard to look at if I just dump it to the screen. So let me quickly just make it JSON-y so it'll look nicer when I print it. And it also shows that, like, this is something you can then do with your data after you get it back, is like, turn it into JSON and make it into an API. Whoops, oh, I spelled that wrong. There it is. Okay, so you see we have all our nice little results in little sort of JSON objects. And we've got only docked bikes in there. And average ride times and things. And there were some things I even did in the SQL to make sure, that the date wasn't going to tell me it couldn't be serialized, and all those kind of things you've probably seen happen when you try to dump things into JSON. You got to be a little careful with that. And I didn't want to have to write a lot of code to like handle that in the JSON dump, so I handled it in the SQL. I just converted everything before I even returned the results. And that's another thing that this kind of thing makes possible, is I can decide stuff like that even when I'm writing my larger program, right? Do I want the database to handle this, or do I want my procedural code to handle it? So that is, I think, the demo. Now let's see if I can get back to my notes. Yeah, here we go. So I've actually found having a little guide to be pretty useful. I have this larger project that I maintain on GitHub called Nerium. And I think of it as like the smallest possible sort of reporting and analytics software that what it's for basically is sending queries to a database, and then it will essentially, using Flask, you can, it creates automatically sort of JSON endpoints for each query that serialize the results just out to the web as like JSON, so that then a front end could consume that and basically get data that it needs to then create a chart and present to a user in a report or something like that. And you can by formatting the URL correctly, you can even pass the keyword arguments that need to get bound to parameters and do all the stuff that sqla-raw can do. Plus, it's actually it's then talking to a web service. And in fact, this is actually a good case of like Nerium was first, right? This was one of the places where like I was originally using records, and then I was using my little cheesy db.py script, and then now it actually, Nerium just imports sqla-raw. I also use it at work for monitoring a bunch of Postgres databases. I have some code that uses AP Scheduler to just read a folder full of SQL, and then every configurable seconds, I think I run it every 10 seconds or something like that, it just runs all those queries, takes all the results and saves them into a timestamp table. And then there are kind of metric thresholds that if they get crossed, the code will send an alert to me on Slack. And so that's all just like sqla-raw under the hood. I even wrote a little headless CMS. I would say it was a fun experiment for me, but I actually learned a lot about why people would write an ORM. I literally did a thing where it's just like you can save articles and you can put tags on articles, but the whole controller layer of it was just me writing SQL statements. with various parts of it parameterized or templated. And I was like, oh, this is why people have ORMs. Like, obviously, if you're writing, the front end of a very like transactional application, you're not even really writing queries at that point. You're just kind of writing like CRUD operations and interactions. And I think it makes sense to not have to be thinking about how does this turn into SQL every time. But it was kind of fun to write, and it might be entertaining for someone to go take a look at that. It is out on GitHub. And then I use this all the time for just little stuff I have to do. I'm a database administrator. I need to automate little things, or even just run something where then I got to get some data, but then I want to do something to it, before it gets sent to someone else. And so again, I was always kind of copying that little script around, and now it's just, it's a thing I just install and import. I was going to, I don't want to spend, I'm sort of running out of time here, or what I said was going to be my time. So I don't want to spend too much time talking about the limitations of this. But, the point of it is that I made decisions here, and some of them I'm not even 100% happy with. But I think it's sort of, engineering life is kind of like that. It's a series of trade-offs, and you kind of make the best bet that you can. The one that really bothers me, I will stop and say, is that so far, at least, and I might have to go back and kind of implement this somehow, there's no paging facility built in. If you ask for something that returns a lot of results, you get all the results right on the wire or into your memory or whatever at once, and that's not great in a lot of cases. Now, I think there's a workaround for that already, where you could do it in the SQL, especially with the like Jinja filter part. So if you wrote your SQL carefully, you could set it up so that it would handle the paging, but it should have something, in it. I think most things that are like this do, and I'd like to have it. I think it would make it more usable for like more people than just me, and maybe make it into a larger thing. Hopefully I've given you some kind of an account of this so far of, like I said, why I kind of wanted to have this, and then how I got there. So I was going to try to sum up with some of the stuff I think like I learned along the way. And I felt like this was definitely a case of me applying, what they call the DRY principle, do not repeat yourself. And in particular, Martin Fowler's rule of 3, which I think I can sum up as saying, if you need to implement the same logic more than 2 times, you want to refactor that into something more general, right? I think I almost, at this point, have internalized that so much, I almost intuitively did that, right? Like, I'm pretty sure the point at which I said to myself, hey, I'm grabbing this db.py and using it again, it was like the 3rd time, right, that I said to myself, oh, I might want to handle this some different way. But see, it's cool. I think this pave the cow path thing is important too. It's cool that I did it as I went along at first, working on things, and did this when I needed to, when it made sense to. I didn't do it the very first time. I didn't try to anticipate, oh, this is a general thing, because I don't know what's a general thing until I've done a few specific things for me, I think, I think there's also a choice between, do you want to use some library that's already out there, or do you want to like roll your own, right? And of course, if you use something that's already out there, if it does what you need it to do, it saved you a bunch of effort. I think that's always worth considering. But there's a lot of benefit, that even unexpected ones, that come, I think, from owning the code yourself and knowing it yourself. You can certainly, I think I've tried to show some of the ways in which, as small and as, kind of doing one specific kind of quirky thing that I think this module is, it's fairly opinionated. It's kind of wrapped around my ideas of how I want to do this, which might not work for someone else. So you get to be as opinionated as you want, and they get to all be like your very own opinions, which is nice. But then also, if there is any problem with it, if it breaks something somewhere, I don't have to wait for somebody else to fix it, right? And so, that's kind of cool. And then I think, I put in this line about don't be shy about using PyPy, and I'm not quite sure what I mean here. I guess it's like, I was shy about using PyPy, and I still am to some extent. Like, I think there's, NPM is starting to have a reputation for being kind of a wasteland of just litter, right, at this point. And there's a certain amount of debris like on PyPy as well, and you don't want to like contribute to that. But it is there. You don't necessarily have to have made, the next like Django or something to be able to upload something to it. It's a part of the community. It's something that's there for us to use. And even if nobody ever picks up your library but you're not going to step on some name somebody else needed or something that doesn't let you do that, right? So even if only you use it, it certainly makes your life easier to just be able to like kind of import something and know that it's kind of taken care of. And then the very last thing is how cool it is to share this. I'm not really great at, I'm not big on, like self-promotion, and that's not what this is about. But I think like just, getting asked, like mentioning on Slack that I had written this, getting asked to do the talk, agreeing to do the talk, it's like, just by I think the same day that I agreed to do the talk, I went and obviously and like looked at the code and almost immediately was like, like there were a couple things I wanted to kind of clean up and fix just because I knew probably more people were going to be looking at it. So that's one thing, it kind of ups your game. But then also, people might have ideas and it's out on GitHub now. I would welcome any contributions, and it just, I think doing stuff in the open, I find, especially because I believe so much in the power of iteration. You can start with something very small and it can become something just kind of incredibly powerful, cool, kind of step by step. And it can even go, grow into something, who knows, what it could be. That is already powerful if even just kind of one person is doing it. But if you do that, as I say, in the open, you both have the energy of more people and the possible effort of more people. But also, like I said, I think it kind of ups your own game. You're less likely to cut corners if somebody's watching, I think. So that's what I had to say for this evening, I think. Ali, are you around? Are you going to come back?
Yeah, thanks so much, Thomas. Can we all give Thomas a round of applause in the chat? Just one second. Let me just hit my enter. Got some emojis copied and pasted. Also, that was great. We do have a couple of questions, but I just wanted to say, like, I really like the idea of reducing the footprint of something like you don't need in order to only use the parts you need. Like, it just makes a lot of sense. Like, it's just part of good development. Like, you don't need everything that maybe Pandas is not the right example, but like SQLAlchemy, like you don't need that ORM. You just need what you need. And I definitely think like more people should think about how little of the library they actually need to use and how much they actually need to test if they don't do things like this.
Yeah, no, I actually one of the things I did and how I found out as much about SQLAlchemy sort of under the hood, as I now know, is like one of the things I did was I looked at whether it was even possible to do this and take another tack at it, right? Like, because even this is like, I'm not using all of SQLAlchemy, but like I have to load all of SQLAlchemy, right? And I was wondering whether it was possible to sort of keep the engine part that I like, and I was going to fork it and like break the ORM code out separately, or I wanted to like see whether I could just like do a thing where I had my own just connector for all the databases, and I was like, no, that took forever for them to do. To have all the connectors that they have and all the dialect knowledge that they have and stuff like that, that's a lot more people than just me, for a lot more time than I've been working on this. And so I think in the end, I decided basically that like the engine is excellent and powerful and valuable enough that it's worth bringing along like all the ORM code, even if my Docker container is going to be a little bigger or something, right? Yeah. But it's not going to actually have to go into that code and execute it. So I don't think it's really slowing anything down.
Yeah, definitely. It's just takes some time to load.
Yeah, I think there's two things. There's the paring down, and then I think the thing I kind of learned this from records and from the guy that wrote that. I like taking something that has a sort of low-level API and just wrapping it, so you bring it up kind of a level, you can improve the interface, at least for yourself, and that pattern. That's really what he did, I think. Ken reads, he wrote requests and just a side benefit of that is like the code that you're implementing all of this stuff in, the tests are so much easier. You don't have to test SQLAlchemy. You can just test your one facade. And that's the other thing. Yeah, right. Yeah. Don't test something that somebody already tested for you.
Yeah. Cool. So we have Joshua Herman. He asks, do you have any good advice or tips when designing a tool that's going to be used by others?
Wow, that's interesting. I try to think about that, right? Like I certainly once I decided I was going to package this, that's one of the things I was looking at, right? Is like how, and fortunately it was already inside of this, it came out of this larger thing, Miriam, that I wrote, which has that's something I'm really hoping. I mean, it hasn't yet, but I think it has 4 stars on GitHub. Woo, go me! But I would not mind if that caught on somehow. But I don't know how to do that, you know. But my point is that I do think about that. I do want people to use it, and so I don't know. I guess, you know, once you've realized that this thing that you're going to do is going to be more something like a module, then it's like how general can you get it, but without making it too hard to use, right? Like at a certain point, if things get too abstract, they're actually harder to work with, right? Because they're harder to reason about. But so I think it's if I try to think of myself maybe as being a good example of the usability that I want, and then like design for myself, but also, you know, try to think of a more general case than just mine.
Yeah, I mean, like, I think like going back to like the rule of 3 that you're talking about, like once you start using your API, you get a sense of like what works and what doesn't work. And another thing that I always like doing is like go to the libraries that you know like have a good interface for you personally. If like see how they work. Like maybe you can use like decorators in a way you never thought possible.
Oh, I stole a lot from records when I was writing sqla-raw, and I also you just made me think of a really good example, I think, for this, which is that Jinja piece, right? In my thing, the way that I implemented that the first time was I used to have, because I didn't want it to always execute that code, right? So I just had an argument. It was like, if you're using Jinja, then just say Jinja equals true, right? When you call it, otherwise don't. But then what I found was I played around with it for a while. I just used it myself, and I think I was actually, ironically, getting ready for this talk. I found this error, which is that if you have Jinja in your SQL, but you don't tell it Jinja, if you don't say Jinja equals true when you call it, then you get an error because it's like bad SQL. And I was like, oh, I can't do it that way, you know, like that. So that's when I changed it. I was like, oh, I better just. So now it has. I just came up with a little regex that just looks for Jinja template tags, and if they're in there, then it renders to Jinja through the Jinja before it executes the SQL. And if they're not in there, it doesn't. And it's just kind of, it's a little bit more magic that way, but I think it's safer actually.
I mean, I think like that's
these
one
are
of like,
these are all kind of choices that I'm making.
Yeah.
And it's like I could be wrong. Like you just have to decide, and then now someone else could use it or not, or it could be an inspiration for someone to do their own thing that implements. You know what? I don't want that whole Jinja thing in there. It's risky. There could be SQL injection. You know, throw it out.
And like magic, it's like it's good because it makes your interface cleaner. And as like a library designer, that's like one thing that matters more than anything else is your interface. It's not about like the actual implementation.
That's right. Yeah. But I don't personally have taste for too much magic.
I definitely hear that. Like too much JavaScript always annoys me as well. So we had Harry Chin asks, what about just using logging.exception to deal with things when you're talking about bringing those up and surfacing them?
An excellent suggestion. Why don't you make a PR?
Awesome. I love the call to action. So if anybody else has any questions, I actually had a couple written down.
No, seriously though, it's a really good suggestion, and I just never thought of it. I always, as honest to God, you would think a DBA would know this, but I swear to God, I forget about logging all the time. I never do it. I'm terrible at it.
It's like figuring out how like libraries work and how other people expect them to work. That's like something that you start just iterating on and just getting better at the more you work as a developer.
Also, so much of my stuff runs in containers now. That one thing about logging is it's just kind of like you just everything just goes to standard out, which I guess you can also have. You can have logging. You can have Python logging. Totally do. I understand that, but you sort of don't even need to have to because everything you want out of it is just going to go out. Yeah. Anyway, but no, logging is just the right thing though for sending a different message that you don't really want to have to consume. It's such a great idea. You should do it. Send it to me.
Yeah, and it's like you just got to figure out like for API design, like what's the best way to send that information back. Like it all depends on what's working for you. Like some people send back a dictionary, others like raise an error and then sort of just like only have errors or like in that particular response versus always sending back like a null error.
Right. Yeah.
So we had a question from Yang. I'm not sure if I understand it totally, but it's like, should we treat this tool like production, like a product dev? I am not quite sure what this means. So, Yang, if you don't mind, just like sort of clarifying your question. Until we wait for that, one thing I was sort of curious about was I saw this library was version 0.2.0. So, like, when are you going to decide that this?
It might be up to 3.1 or something now, but yeah,
Okay.
but 0.3.1,
Yeah.
yeah.
So, how are you going to decide that this like library is done? Like, what are your sort of goals?
Yeah, it might be already. Honestly, I've made this joke before, but it really applies to me a lot. Like, if you take semantic versioning seriously, then like you have to just like have, it just takes guts to like go to version 1. I don't know. I'm not sure. I think I'm about to do it on Narium. Like I know what to do to get there. It's a lot more work than I want to do. Mostly because it needs a lot more documentation. But this could probably be like 1 dot something maybe now. I mean, maybe more tests. Or especially like what I did for tests for this was I put a sort of assert statement in the dunder main of the script itself. So if you call it directly, it runs a quick little query and makes sure that it can, right? And it's just a dumb little thing so that if I break something, it really does work like a test, right? Like I can actually check, I can go in and break something and run it and it will fail. But it should be in its own little test script or test.py or something. And if nothing else, and I think actually I have no tests covering the Jinja part. I would like better test coverage maybe, and maybe paging, but I don't know. It does seem like it takes nerve somehow. You're saying like this is this is it. I finished it, and I never feel like that about anything that I do. So I don't know how to go to 1.0, but I'm gonna have to just I think my wife would tell me. Well, I shouldn't repeat that on the air.
Well, I mean, like, how long did it take to last?
Something I need to take out of my purse, let's say. But that's a weird. That's a front.
No, but just like Flask just went 1.0 after like 7 years and like hundreds of companies making billions of dollars on top of this platform. So it's like absolutely crazy. So one thing I get
why he was so shy about it. I feel the same way.
Yeah. So one thing I did want to point out was, have you heard of Flit? It's a tool that lets you upload packages to PyPI. It makes packaging things a lot easier. So if folks are looking to get their tools out there, FLIT. I'll also post a link to the chat.
Oh, I've never heard of it. That sounds interesting. I don't find.
I got a recommendation, and I've been using for the past 4 or 5 months. I don't know what Twine is. I don't need to know anymore. My life is a little bit better.
Sure. I have no problem with Twine, but I will look into it. It sounds interesting.
And so I think that's it for questions. Before we let you go, do you have any words of wisdom or any advice or takeaways or shout outs for our audience?
I shout out to all my BenchPrep people who I think are this evening. And I would say, honestly, I meant it earlier when I was kind of giving the guy a hard time about sending me a PR, but really, contributions to this would be, or to any of my stuff that's on GitHub, that's public. I obviously have some private stuff for my employer, but anything that's public, I would welcome any interest or contributions to. Always happy to get feedback or file issues, even just give me more work to do. That would be cool. I think I really do like part of what's been great about my career is getting to participate in just the open source community and make contributions to that community, and I think there's hopefully there's some worth in the stuff I'm making.
I mean, like just putting yourself out there, I think is fantastic, and sharing your knowledge and sharing the things you've done have been great. I've definitely learned a lot. Can we give Thomas another round of applause in the chat? All right, thanks so much, Thomas. We'll see you next time.
Okay.
And so that was Thomas Yager-Madden talking about his tool, sqla-raw, but it was really about building tools and reducing the interfaces of the tools that you're using to fit your specific use case. We're going to be taking a 5-minute break, and then we're going to be coming back with Stephanie talking about anomaly detection. We'll be right back. All right, we're back. Welcome back to the Chicago Python Data Special Interest Group event. My name is Ali Sivji. I am your host for tonight's event. We just had Thomas Yager-Madden talking about how to reduce the interface of SQLAlchemy with a tool he built. It was really more of a general talk on building like a toolbox for you and then just putting it out there. Next up, we have Stephanie Kirmer. I'm just going to bring her onto the stream. Hey, Stephanie, how's it going?
Hey, great. Thanks for having me.
Thanks for joining. Where are you calling in from?
I'm in Westtown. Yeah. So
okay, awesome.
Chicago.
I love it when we can just say like neighborhoods versus like cities. It makes me feel a lot happier.
Yeah.
So can you please introduce yourself to our audience?
Yeah, I am. My name is Stephanie, and I'm a senior data scientist at a startup called Saturn Cloud. We built a platform to help people run Python for machine learning in parallel with GPU clusters, and we sort of manage all of the backend architecture so that you don't have to worry about the DevOps, but you can just do really fast, cool machine learning. And so I have a sociology background, and so came to data science several years ago and worked in a couple of different startups in the Chicago area. And I also worked at the University of Chicago doing research and program evaluation for criminal justice and education. So.
Awesome. So how did you first get into Python?
You know, when I was deciding to sort of change my career from a project management type of stuff that I was doing into a more data focused role, I took this Coursera like MOOC online class called Programming for Everybody with Charles Severance, and he teaches in Python. And it was a just life-changing moment. It was my first time using Python, and it was like explaining the underlying concepts of just like development and coding using really comfortable, easy to understand, accessible Python. It changed my life, and I've never looked back. So yeah, he still has that course. It's still on Coursera if you want to try it.
And so going from like that general Python course, how did you make like the pivot to data?
Well, I had always been interested in data. I had my sociology background was quantitative sociology. So I used large survey data sets and that kind of thing. But I got interested in working more in data while I was working at DePaul University. I got interested in helping to determine for the office I worked in how international students were performing in how they were finding success in classes. And we were evaluating, you know, are we giving students the support they need, and are students having a positive experience at DePaul? We did surveys and things like that. And that data really brought back my love of doing data analytics that I had back in grad school. And so I, from there, took slightly more data focused roles at the University of Chicago, and then at Uptake, and then, you know, now moving into the work that I'm doing at Saturn Cloud. And so it's just gradually gotten more and more data until it's, you know, everywhere.
Yeah, and I think that's like great advice for career changers. It's like, can't just jump in all the way. Just gotta like make those incremental improvements in yourself and like your learning style.
Yeah.
Sorry,
go ahead.
No, I was just saying a lot of our community members have sort of been feeling like isolation with the effects of coronavirus and being stuck at home.
Mm-hmm.
Like I've been coping with this. I want to call it my podcast, but like with this live stream, it's just like made things a little bit more fun for me. How have you been dealing with the effects of the pandemic?
Well, I got more exercise equipment, and I have exercise equipment at home now because obviously I'm not going to a gym, and making sure to exercise every day has just like been a huge game changer for me. Even if I'm not like going out, if the weather is bad, knowing I have, you know, the stuff to do it at home is really key. And also trying to keep up those social interactions as much as possible, you know, seeing people, you know, this way instead of, you know, seeing people in person. It's not the same, but it really, you know, it helps. And, you know, avoiding that tendency to become isolated, I think is important.
Yeah, and I think we're all realizing we're more extroverted than we originally thought, especially like in the tech industry.
Yeah, absolutely. I think we didn't know that we were going to miss seeing other people every day so much, but now we do. Yeah.
Yeah, for sure. Are you ready to start your talk?
Absolutely. Yep.
Can you share your screen and we'll just get it up?
Yep. Let's get moving. Okay, here we are.
Awesome.
So I'm going to start.
Take it away.
Yeah, so I'm going to start with a little pitch for my company, of course, because Saturn Cloud is awesome, and anybody who's working in Python is probably experienced the time when, say, Pandas doesn't hold all the data that you need, or you're, training the most awesome model ever, but it takes an hour to train, and that makes the iteration process really difficult. And we have free trials, as you can see, and you're welcome to visit saturncloud.io to learn more about what we offer. It's a really full-fledged platform that lets you work in a Jupyter or script environment, and we handle all of the gnarly stuff to allow you to use clusters or parallelization with Dask to make your processing faster. So with that said, that is not what I'm talking about at all today. One thing to keep in mind is that all of the stuff that I'm going to be going over today is on my GitHub. So you can either visit stephaniekirmer.com or just go to github.com/skirmer to see material that we'll be talking about. I'm also doing a version of this in R in December for Our Ladies Dallas. So if any of you are interested in this and would like to see not just the Python implementation that I'm showing today, but the R implementation, that will also be something that you can watch remotely. So with that said, what I'm actually going to show you today is a Jupyter notebook, but I'm going to use the Rise extension to show it as slides. And this is one of the coolest things that I learned while preparing this talk, because I did not know exactly how to use Rise to do slides before. And preparing this, I got to learn it. Trust me, you really need to try it if you have any presentations to do with Python code. So what I'm going to show today is we're going to start with talking a little bit about how isolation forests work, what it even is, and then what that means for approaching anomaly detection problems. So particularly if you're working with, highly voluminous data where there's a lot of numeric characteristics of each point, an isolation forest can be a really neat way that is particularly easy to do computationally without a ton of extra resources, to produce anomaly detection models that can be translated into business use cases or whatever you might have. One last reminder, if you want to talk to me online, hit me up on Twitter, Data Stephanie. I'm happy to respond to comments or questions there after today if you have further things that you think of that didn't cross your mind while we were on the presentation. So what the heck is an isolation forest? Let's get this first. So when you're doing tree-based decision-making, you're splitting up observations into subgroups based on the characteristics of the observations. And so you might be thinking about this in terms of classification problems, naturally. But what you actually also can do with this is discover that the shorter the walk from the original decision to a certain point, the fewer breaks required to isolate that point, the more, say, anomalous that point is in terms of the overall data set. So that's the concept that isolation forests use to sort of foundations of this whole methodology. And we're going to get into showing a few different examples and sort of use cases for it in a minute. So if the tree thing doesn't really click with your brain, then there's also this other way to think about those points in sort of a two-dimensional space. Say, if you're trying to isolate a point and it requires very few slices in your two-dimensional space to get it all by itself, then that's highly anomalous. So the B side here, for example. But if it takes tons and tons and tons and tons of slices to get it by itself, if it's right next to a bunch of other points, then not as anomalous. And that's the characteristic that you can also use, right? These are two visualizations of roughly the same concept, the same way of identifying the points, but just a different way to sort of think about it. All right. So if you wanted to follow along, you can also, of course, get that notebook on GitHub and you can run this all by yourself. But there's a few things I'm going to be using, some notebooks, some libraries that will be used in this notebook. just for your reference. I'm going to use pandas and NumPy, like you do, to do the sort of data munging stuff at the beginning. I'm going to use sklearn and the SHAP library for Shapley values to do some feature importance a little bit later on. And then I'm going to do a ton of visual stuff because I really love doing data visualization. And although it's not R, Python does have some really cool tools that are sort of emerging on the scene that give you a lot of opportunities to do really cool stuff in visuals. So we're going to use Bokeh, Plot9, Plotly, Matplotlib, and GraphViz for this. So you have a lot of exciting stuff to see in the moments to come. So the data set I'm using is a data set that's publicly available on Kaggle, so you can go pop in there and see it yourself. It's a data set of Spotify music tracks. So what we're going to do with this example as we walk through this is we're going to take musical tracks. We're going to take the characteristics of those tracks, which are these, and we're going to use these to identify tracks that are anomalous from the body of the Spotify, sort of listening experience, if you will. And there, you can see that there are some characteristics in this data set that are about the sound of the track, so acousticness, danceability, instrumentalness, and so on. And then there's some that are more categorical features of the tracks that are things like the release date and the name, which we're not going to use those as the features in this model. We're going to use the year, but we're going to use it in a bin. Okay, so let's look at some examples to see what it is we're really talking about when we're talking about these tracks here. We try for a high instrumentalness, and we take a quick little random sample of a couple of these tracks. What do we get? We get Miles Davis, sounds instrumental to me. Bach, sounds instrumental to me. Okay, I think we're getting the right track here. We're getting songs that make sense for the what characteristics we've asked for. So that's good. We want to make sure that the data set makes sense and is kind of on board with where we're going. Let's see, speechy tracks. Rodney Dangerfield, I'm expecting him not to be singing. That sounds good. And there's a few other ones here that I don't know a lot about them, but we're just going to have to assume that speechiness is giving us what we expected. Loud tracks. Yes, the Stooges are going to be loud. I can definitely confirm that. So, okay, it looks like we've got loud tracks that should be what they are. Great. So this gives you an example of like what we're looking at here. I'm not going to spend a ton of time investigating what the actual characteristics mean, because more importantly, what I need to know is that as long as the track is different from the bulk or from the average, so to speak, of the other songs in the pool on that field, on that characteristic, then it's anomalous. And it doesn't really matter to me what does, valence really mean. And it means happiness and sadness, incidentally. Okay, so a little bit of feature engineering, just not much at all. I'm really just going to cut off the songs before 1960 because we're missing some data, and it's a little bit sort of the data quality is a little different before that time. It's not that it's bad necessarily, but also I'm not sure that we are going to have a lot of ability to recognize songs before 1960, and it was more fun to look at songs that we recognize or songs that we might know. And then I'm going to do a binning of the year, just so we group the years a little bit, because each individual year is a little too granular for this. And we want to kind of give it, roughly decades, not quite, but on the ballpark. So we've got this feature set. These are the characteristics that I'm actually going to use. So we've got our instrumentalness, duration, popularity, key, and so on. And then I'm downsampling a little bit for the graphs, just because for visualization, especially like this, when we're flipping through the slides, I don't want to sit here and wait for things to, run to, or have things be so voluminous that the plot is completely filled and we can't see anything. But I've randomly downsampled, so the characteristics of the underlying data should be represented accurately. For the model, we're training on everything, so that's not a problem. All right, so I'm going to train using the sklearn ensemble isolation force module. It's built right in. You don't have to do any customization at all. It's right there waiting for you, which is really nice. There's also, of course, implementation of this in R, which you'll get to see in December if you come watch me at Our Lady's Dance. Okay, so this is our function to fit the model. So I'm just handling a little bit of missingness, and then what you'll see right here in the middle is the actual model is initialization. So it takes a few characteristics that are not going to be particularly unfamiliar to anyone who's working with random forests or things like that. You need to figure out exactly, you know, sort of the samples within your trees and that kind of thing. But by and large, I don't think that this should be particularly confusing. You can certainly customize these and sort of you know, do some hyperparameter sort of grid searching through this if you want to see what's really going to work best for your data. In this case, it's just an example, and I'm not, you know, worrying too much about it. So then what we'll do in the end is we'll calculate the predictions. We'll also do a string version of the predictions so that we can just easily see anomaly normal. So the actual model, the isolation forest in sklearn will return a couple of different things. It's going to return the decision function. It's going to return a numeric score, and then it'll return that -1 and 1 for either anomalous for -1 and normal for 1. And we don't want to have to remember which one is which, right? So we'll just give it a string version so that the graphs later on can show that. So other than that, we're really just run the model just the way it is, and then we'll be right on our way. So then I've got a function to predict on the new version as well. So we're going to use a training test split, and then we'll use the model object that we trained on the training sample. Everything should be very familiar. Nothing really fun to see here. So we've done our train test split, doing a 70-30 split here. And then I am fitting the model on the training sample using just those features that I listed up above, remember? So we're not going to include the categorical ones or get into anything, you know, too wild and crazy. And then the new train sample, we're going to show here just the list of the actual results that the model produces. So this is not all of the extra features and things as well, just what the model is actually returned to us. So a 1 is normal. The decision function giving us this sort of the way that the model is assigning the break between normal and anomalous, and then the actual numeric score that it gave. Okay, so we predict on our test holdout. We get something that looks very similar. We've got our prediction, we've got our text version, we've got the decision function and the scores. Easy, nothing really complicated about that, but let's look at the results and see what it actually decided, right? I first want to look at the feature importances because it's interesting to see what is most valuable for isolating our observations. This is going to tell us which of these breakpoints isolated features or isolated observations the most effectively. And so we've got some interesting stuff, right? We've got a few different things. The feature impact on model output, we've got speechiness, duration, explicitness, instrumentalness. There's a few interesting features that's kind of cool. One of the things that I found particularly interesting, I don't know the answer to this, by the way, how Spotify is defining explicitness might be something really interesting for, you know, someone to go in and investigate if you feel like doing so. But this is just, you know, a way for us to get a sense of what the model is interpreting and what it's coming out with after the training and the test sample. All right, so let's look at what we got. So 97%, almost 98% of all of the songs that we got ended up being not anomalous, and we've got about 2% anomalous in the test sample. Okay, that seems reasonable. And then in the training sample, almost identical. It's not exactly the same, but those distributions look very, very close, which is great. That means that we've got representative sample that we're using on our training, and that the test sample is giving us a similar sort of approach. So here's a quick way to visualize just two features against each other, and then we're color coding based on the anomaly status. And so I hope you can see this reasonably well. It's a little bit small, but we've got speechiness on our y-axis and tempo on the x-axis. So if you figure that a song is unlikely to be spoken and not musical, and also very fast, then this is the sort of thing that you might see. And really, what I discover here is that there are speechy songs and there's everything else. There's a very, very bimodal distribution between those two, which is kind of neat to discover. And we're really not seeing a difference across the tempo levels at all. Like there might be some distribution difference in the tempo and across anomaly, but that high tempo, high speechiness category just doesn't have much in it at all. So that would be sort of our far right all the way at the top. Cool stuff. interesting to figure out. And we're using Bokeh to do this visualization. So that gives us a lot of neat little customization possibilities. You can do zooms and things like that if you're so inclined. So, you know, that's fun. Okay, so get it moving on here. Okay, so then now I'm going to show a plot tree. So we're going to look at the actual trees in the forest, right? So we've got an isolation forest and we're splitting off based on breaks that the model is determining in order to isolate features most efficiently. So here is a tree, right? This is just grabbing one tree out of the, I think, 300 that we decided to have in this model. So there's a lot of trees here. So this just picks one, and we start with duration. Short to the left, long to the right. And then beyond that, you can see the breakpoints as you go. GraphViz is super cool, by the way, in case you haven't used it before for visualizing trees, highly recommend it. So what we can see here is, okay, so we've got duration is short in milliseconds, which figuring out what this is like in minutes to milliseconds, I'm not going to go trying to do those calculations in my head at this moment. But so then we've got 300 samples, and now we get 209 go to the short side. Okay, so we've got some really long songs over here, only 91 now. So then if we go to the long side, we get loudness, and loudness is low here. So if we're going for, so we've got duration, tempo is low, so slow song, loudness, quiet song. And now we're at 2 samples here. It's very long, very slow, and or fast. Sorry, no, slow. It's true is to the right. No, true is to the left. Sorry. So loudness, and then we get down to single samples, right? And so I'll just give you this example on this far side, is that when you break by these particular characteristics and you get to the end of the points, these are isolated, and that's exactly what we're trying to achieve here. We're trying to get anomalies that are isolated fast with fewer breaks from the top point. These, you know, ellipses over here show that we have many more samples going down in longer trees down below that I'm just not showing you here on this particular visualization. But if you wanted to, using GraphViz, you can show more and you can look at the different parts of the trees. So another thing that I thought would be interesting to do is to apply PCA, principal components analysis, to these features to see where sort of our outliers appear. If we find that we can do this PCA and see outliers on the margins of the sort of body of the data, then we probably getting what we wanted and probably having things work the way that we expected. And also we get to use Plotly, which is super cool, right? So here I'm showing points. We've done a 3-feature PCA. And if you look at these points, you can see there's a very interesting sort of V shape to the data overall. And we have a lot of anomalies on the outer end of one of the Vs. And then if we look at it from the other direction, you can see some sort of more on the upper angle there, but not a whole lot. And looking at this in 3 dimensions, I just find this fascinating. I can look at this all day, to be honest. But I like that being able to see that this sort of area in our 3-dimensional space is where some of the bulk of anomalies are showing up. So this is another thing that you can do with your anomalies as you've got the sort of prediction characteristics from the model to see, do a double check to see where it is your anomalies are really showing up, even though because it's PCA, you can't necessarily reverse engineer this back to the original features. This can give you a way to envision the data that you didn't otherwise have. All right, couple of other quick little things that I'm going to explore before we get done. I'm curious to make sure that our anomalies are not, skewed to one or another time period. I've broken the dates up, and you see that the automatic splits didn't come out on the exact year, but that's fine. We don't need to worry about that. But what I do have are showing the different scores by year and showing the proportion of each year that's considered anomalous. It looks pretty good. We can look at it actually by these numeric values and see that, yeah, by and large, it's not showing a situation where all the anomalies are skewed to 2020s or 2010s or vice versa. So this is important to know that we're getting anomalous characteristics that are within comparison to the year as well. I'm also enjoyed just making this little visualization because this tells you that we have The bulk of our scores are somewhere around here. This is the score feature. That this is one of the things that the model just generates for you. The bulk of our scores are in here in the -0.43 range, give or take. So, you know, in this section. But our anomalies are showing up well off to this side. And if you were to be setting your own function for the slicing barrier between these two, you might want to make sure that you run something like this to ensure that you're not overlapping your normal and your abnormal scores and having trouble with the actual division of those two. You want to see that this bulk in the middle of the non-anomalous, the normal feature set, the normal observation section is well away from your anomalies. So a couple of things I want to do a quick spot check just because I'm interested. And I want to take some of these Shapley values that were most influential, that just because these feature importances can be handy for finding out what you're going to look at. And let's go back. So we started off with spot checking. What are loud? What are, speechy songs? Let's see what we've got. So here's an example where we can take, just a set of the data, look at some of these songs that we might be familiar with, and we can see all of their features. Oh, pardon me. This is actually selecting songs that are highly speechy, and then we can also see that I'm afraid that it just didn't return me the characteristics that I'm filtering on, but it's filtering on highly speechy. So I'll just skip past that. And then looking at the branches, we've got durations in milliseconds. We've got high tempo, so low duration, low tempo, low danceability, and low instrumentalness. Let's see what kind of songs that this returns us. These are some songs that I'm not particularly sure I know a lot about, but I do know that these features that we're looking at, they fit the categories that we're looking at. One fascinating thing that I discovered while doing this too is that there are some songs that you'll find in this data set that are white noise or silent or rain or things like that. And those tend to have zeros in certain categories. And so you'll actually find that those are more likely to be marked as outliers because there's just absolute zero in certain areas. Like, well, white noise is not going to have a tempo or danceability, and that makes sense. So that's a kind of interesting detail that you can find when you're looking at data like this. One other sample that we're going to look at. So what? Long, speechy, loud, and explicit. Let's see what that gives us. All right, we've got some rap songs. That makes sense. They're going to be speech-oriented for sure. And then particularly some of these Eminem songs, it sounds like he's getting explicit with the language. And so, that's kind of interesting. And explicit, it turns out, is a binary variable. So it's just either it is or it isn't. All right, so to recap. Got that data set, looked at it a little bit, made sure that we knew what we were dealing with and what sort of whether this data set was reliable and trustworthy and something we wanted to use. Did a little bit of feature engineering. So training that isolation forest, and we examined some of the results after we've done the prediction. Got that PCA to confirm that we're getting outliers using the three-dimensional space, and then we did a little spot check. And you can use the same kind of use case and work through these same sort of methodologies for use cases of your own when you're using any kind of numeric data to classify observations as isolation anomalies or otherwise. I've got a couple of links here. You can get all of these on GitHub as well. Rise is the tool that I'm using here to do the slides, of course. A Plot9, awesome visualization tool. And then there's some here about GraphViz and about using isolation forest and that kind of thing. So I encourage you to check them out if you have other opportunities to use it. All right, so that's that. Thank you so much, everybody, for joining us. And then I think that is the end of what I've got to share. Allie, I think you're muted.
Thank you for that. Yeah, thanks so much, Stephanie. Can we please give Stephanie a round of applause in the chat? That's very interesting how to use like random forest to detect these outliers. So like while we're waiting for questions to come in, I was curious, like when in your data science life cycle would you do this? Like, would you do this before you start doing your EDA and remove your anomalies? Like, what's sort of like the point in time people should start looking at this information?
It's a good question. I think it depends on the sort of problem you're trying to solve. Because so anomaly detection can be its own, like isolation of abnormal points can be a problem unto itself that can be the endpoint, right? Say if you're trying to find fraud or something like that in a data set, like credit cards or something, right? So you're not necessarily going to do this to identify anomalies that you want to remove from your data set. You might just do this because the anomaly is the point and the anomaly is the thing you're trying to achieve. But you also might find that if your data set has an odd distribution of anomalies or something like that, and it's going to have an impact on the problem you're trying to solve, that then you might want to do this earlier on in the process to be able to see how much of the data is sort of, it's like, are there anomalies that are so different as to perhaps be data errors or to be problematic in some other way? But a lot of times, if a data set has anomalies, it just does, and that's the way the world is. And you don't want to remove those. You don't want to take actions necessarily to change the data set. Knowing that they're there and being able to use that knowledge to interpret the results that you get appropriately might be the best thing to do. So yeah, I think there's a few different ways to use it.
Awesome. Are there any other techniques for anomaly detection that you recommend people look into?
Oh gosh, yes. And there's tons. The anomaly detection and sort of this unsupervised learning is a huge, sort of use case for a lot of data science. Gosh, even where to start is the like a lot of people will use like KNN, something where you're identifying a point and then determining how many other points are in close relation to it, and then determining whether it as a point is very similar to those points. So this is all, sort of conceptualizing your data as points or observations in some sort of space, 2-dimensional, 3-dimensional, X-dimensional, whatever you've got. And then that's why we will often use PCA, right? So you'll want to reduce the dimensionality of your data so that you can get it into, say, that 3-dimensional space, and then chop off the funny edges, for example. Yeah, so I think that there are a lot of really valuable techniques out there, and this is just something to add to your toolkit, especially because it's tree-based and random forest sort of algorithm under the hood. It's very interpretable. It's really easy to explain to someone why this point turned out to be an outlier, whereas with PCA, that's not as easy.
Okay. This might just be a little bit of my ignorance with data science, but when you're doing this kind of anomaly detection with the isolation forest, is there a particular type of data that you can do it on, or can you apply it across pretty much any kind of data set?
Well, I mean, as with lots of modeling strategies, you need to be able to convert the features you're working with into categorical or numeric features in some way, right? You need to be able to sort of convert this into a sparse matrix or a matrix type of data set. But aside from that, I think that it can be used for all kinds of things, right? As long as you can create your feature space into in a way that the model can understand and can make those breaks and figure out where the trees should be divided. I think it'll work for lots of things, and I would really love it if people try it on different kinds of data and different use cases, and let me know what you think and how it works. If you find a situation where it really falls apart, that could be very valuable.
Yeah, awesome. Yeah, that's the best way to do it. Call to action. Go out there, make sure it works for you. So Joshua's asking, is this model CPU, memory, GPU bound, or is it
this particular one is really small. This one doesn't need any memory at all. This data set was just not that big. And really, when you're talking about using a random forest or any kind of tree-based modeling like this, it would super well respond to parallelization or using some kind of a cluster-based, sort of modeling, if you have enough data that it's worth it. And of course, that's the sort of thing that we at SoundCloud are very excited about. Parallelize all the things. Use Dask as much as you can. Yes. But for this, I picked a data set that I could easily just run in my little Jupyter notebook on my local machine, and it was totally fine. So yeah, you can scale up to whatever volume of data makes you happy.
Awesome. It looks like that is it for, actually, we have one more coming in. Do you have any anomaly detection pipeline to suggest? Also, when this person was working in medical insurance, they used random forest. And when they're working in bank transaction data, they use XG boosting to get the most accurate results.
There's so many ways. I think that's one of the nice things about data science is that there's not really one true correct way to do a lot of the solving of problems that we have. So I mean, this is always my approach. I have a business problem or something like that. I'll experiment with a few different algorithms to see what's going to respond the best to the data that I have. And you might find that, say that the forest can't really do a good job of dividing up your data because the splits are not easy to identify, or the data is really compact in the sort of three-dimensional space, and there aren't a lot of obvious out in the wild, weeds kind of points. And that may mean that the function to split where anomaly becomes, a problem is hard for the model to do. And so that might mean that another algorithm is a better approach, and you won't know for sure until you test it out. But I hope that this notebook gives you an easy way to plug in your data, play with your features, run through it, and not spend a ton of time while learning whether this is going to work.
Yeah, awesome. And we're going to put a link to this notebook in the meetup, and I'll also add a link to our YouTube comments down below. So check that out if you're watching this a little bit later. So I think that's it for all the questions we have. Are there any things that you would like to just give a shout out to, or sort of just some words of wisdom for our audience?
Oh gosh, that's a very open-ended option. I think that I hope that people can take away the joy of problem solving and discovery and creativity that I get when I'm working on things like this, and that this gives you a inspiration to go out and work on these things with your own use cases. I hope that people find it fun, and they're definitely connect with me on Twitter and ask questions, or chat with me about what you tried, how did it work, because I'm genuinely interested to know more about everyone's experience.
Awesome. And we can feel your enthusiasm come off. So it's like I'm not a data person, but I learned a lot. So thank you so much.
Thanks.
Can we please give Stephanie another round of applause in the chat? Thanks so much, Stephanie. We'll see you later.
Thank you.
All right, so that was Stephanie Kirmer talking about branching out into isolation forest, which is a tree-based anomaly detection model. Very interesting to learn about. Let me just bring my screen up and we'll wrap it up. All right, so if you're still here, you're still watching, you had a good time tonight, go down below and hit that like button. It really helps us out. Lets us know that folks are out there watching and they're interested in this content. Let me get my presenter mode. There we go. Also want to make everybody aware of our upcoming events. Tomorrow at noon Chicago time, we have our lunch and learn session on asynchronous programming. Next month, we have a few events lined up. We have one for algorithm special interest group. There's going to be our main meeting on November 12th. And I believe we have one of the creators of the Python or the new PEP that was out for bringing time zones into Python. We have them tentatively scheduled, so it should be a lot of fun. And then on November 19th, we may do a project night. Sort of just depends on how folks are managing the time going into Thanksgiving. Also want to just let everybody know that PyTexas is happening this weekend. It's going to be happening online. I believe they're going to be streaming talks onto YouTube. If you want to know more information about ChiPy and want to contact us and chat with our community, you can join our Slack. Go to that URL, send yourself a link, join in the conversation. There's 2,000 folks. We're talking about things like what's going on in the Python ecosystem. Folks are also getting help for projects they're working on. And my favorite channel is Pets of ChiPy. If you have a pet, please share a picture there. It's always a lot of fun, especially when we're all sort of trapped at home like we've been for the past few months. We are on Twitter at Chicago Python. All this information plus more is available on our website, which is chipy.org. Thanks again for joining, everybody. Again, my name is Ali Sivji, and we will see you next time.